बिस्मिल्लाहिर्रहमानिर्रहीम जी। ये लेक्चर सीरीज है रीइंफोर्समेंट लर्निंग के ऊपर। और ये हम क्लास में हम ये शुरू कर चुके हैं लेक्चर सीरीज। लेकिन डिसकंटिन्यूटी की वजह से हम उसको फिनिश नहीं कर पाए उस तरह से जिस तरह से करना चाहिए था। तो बहरहाल हम इसको ऑफलाइन रिकॉर्डिंग कर लेते हैं ताकि हम इसको अच्छी तरह से समझ लें। इस वीडियो के अंदर हम डायरेक्टेड ग्राफ को डिस्कस करेंगे। ये डायरेक्टेड ग्राफ है और इसमें अगर आप गौर से देखें तो डिफरेंट नोड्स हैं। फॉर एग्जांपल दी वर्टिसेस और नोड्स इज बेसिकली अ सेट एक्स वाई, एक्स वाई, z, p and w. So these are basically the vertices and there are so many different edges. Edges में मिसाल के तौर पे हमारे पास ये x से y एक एज है, हमारे पास x से p एक एज है, y से p एक एज है। So there are a lot of edges. For example, I can write the set of edges as an edge between x and y. There is an edge. There is another edge, for example, between from p to z, and so on. There are a lot of edges here. Now, with this graph, these are the edge weights. Um, for example, if you simply see this, a cost from going a node X to Y, maybe a petrol cost, maybe any kind of cost. And these are the costs written. And wherever the edge weight is negative, we can think of this as gain, some price or something जो हमें मिलेगा। तो टास्क ये है कि अगर आपको डायरेक्टेड ग्राफ गिवन हो जिसमें एजेस भी हों, नेगेटिव भी हो सकते हैं, पॉजिटिव भी हो सकते हैं, और आपको एक नोड दिया जाए, फॉर एग्जांपल एक्स, you can call it a source node, for example, source node, और आपको एक डेस्टिनेशन नोड भी दे दिया जाए। मिसाल के तौर पे इस केस में लेट्स से z is a destination node, let me call it a target node or something. uh, so the goal is, if you are given the source and target nodes, you need, and you are given all the costs and everything. This is the target node, for example. You're given all the edge costs and everything. So the goal is to find out the shortest path in terms of the total cost. Um, yeah. So in this case, for example, the shortest path from X to Z looks like that I should go from X to Y. I should have this edge. This is my first edge. Now I will be at Y. I could go from Y to Z directly. That is one path, may not be a shortest path. For example, Y to Z, and I have reached from X to Z. The total cost is the 4 of this edge and 2 of this edge, so the total cost is 6. But on the other hand, if we see, I can go from X to Y, uh, and then maybe I go from Y to W, which is the cost is 3, and then from W to Z, which actually brings a gain of 5, and that total cost becomes just the sum of all the edges in between, which is 2. So in this case, this path is better than this path. It may be a shortest path. There may not be another path with smaller total weight than this one, but obviously there are multiple paths from X to Z, and I've shown you two of them, and one of them is better than the other. So the goal is to find out the shortest path from a given vertex to another vertex. So that's the problem we will be solving. Um, well, I mean, the major chunk of this lecture series will be solving this problem, and we will be seeing a vectorized implementation of this. And जब हम vectorized implementation देख लेंगे, उसके बाद हम देखेंगे कि how simply, very easily we can convert that implementation to a standard Markov decision process, जो कि रीइंफोर्समेंट लर्निंग की बुनियाद बनेगा। सो इसको देखते हैं जी।